In this lesson, we are going to discuss the first use of a potentiometer, that is to find the EMF of an unknown cell or to compare EMFs of two cells. So we have a potentiometer which has a cell of EMF E, an internal resistance R, connected to a potentiometer wire, which is a linear conductor of uniform cross section. Now we connect a cell here. The plus of the cell should be connected to the plus of the potentiometer cell. This cell is having EMF E1 and internal resistance R1. We connect this to a galvanometer and we move a jockey on the potentiometer wire and find a point where the current through the galvanometer becomes zero. This is called balance point, and this length L1 is called balance length. Now, if we apply Kirchhoff's voltage law or Kirchhoff's loop rule to this loop, ADEFA, so ADEFA, then we realize that A is at higher potential, D is at lower potential. So the voltage drop from A to D, so let's call that minus VAD. And then we go through the galvanometer. There is no potential drop here because the current through the galvanometer is zero. Current through R1 is also zero, so there is no potential drop across R1. And this is minus of the battery, this is plus of the battery, so we are going up in potential. So therefore plus E1. And then we come back to A. So therefore this will be equal to 0. Therefore the EMF of the cell is equal to the potential drop across AD, that is length L1 of the potentiometer wire, and this is given by Z into L1 because Z is potential drop per unit length. So potential drop across length L1 will be Z into L1. Now if you connect another cell having EMF E2, and if the balance length is L2 for that cell, then E2 will be equal to Z into L2. Now if we divide the two equations, we get E2 by E1 equal to L2 by L1. So if we know E1, we can find E2. And if we don't know, we can find out E2 by E1. So this is how we can use the potentiometer to find the EMF of an unknown cell or compare EMFs of two cells.